The measure of an inscribed angle in polygons. The measure of an inscribed angle is half of the measure of its intercepted arc. So ADB, measure of angle ADB, that is our inscribed angle within circle C. The measure of angle ADB is half of what the measure of arc AB would be. And that can go backwards as well. The measure of an arc would be twice the measure of its inscribed angle. Example 1, find the indicated measure in circle P. So first let's solve for the measure of angle S. Well, let's take a look at where that is. That is the measure, that is angle S, that's what we're solving for. Now you can see angle S is an inscribed angle, and its intercepted arc would be the 60-degree angle. So that means that the measure of angle S is equal to half the measure of its arc, which is 60 degrees. So the measure of angle S is 30 degrees. So now I'm just going to put that in my picture, 30 degrees, just in case I need it to solve another part of a problem in this circle. Now we're going to solve for the measure of RQ. So the measure of arc RQ I highlighted in light green. Notice that RQ, though, does not have an inscribed angle. So that means we're going to have to work with other things that were given in this picture to help us identify the measure of arc RQ. Well, we also know that RQ is connected to QS, and R to S makes a semicircle. So that means that the measure of arc RQS is 180 degrees. I also can see that I have an inscribed angle at angle R. So that means that the measure of angle QRS is 37 degrees, and if I know the measure of that inscribed angle, I can find the measure of its arc QS. So the measure of arc QS is equal to 2 times the measure of its inscribed angle. So the measure of QS is equal to 74 degrees. So I'm going to fill in 74 degrees on my diagram, and now remembering that it's part of a semicircle, I'm going to use 180 degrees and subtract 74 degrees to find what's remaining. So 180 minus 74 is 106, so that means the measure of arc RQ is 106 degrees. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. So let's take a look at this example. Find the measure of angle HGJ and the measure of arc HJ. What do you notice about angle HGJ and angle HFJ? So I'm going to first outline the first angle that we're solving for, HGJ. So notice that HGJ is an inscribed angle and its intercepted arc is HJ. Now if I erase HGJ, I'm going to outline the other inscribed angle in the picture, angle HFJ. Now notice that when I outline HFJ, it opens up to the same arc that HGJ did with arc HJ. So that means that those two inscribed angles are congruent. So that means that the measure of arc HJ, which is an inscribed, which is the intercepted arc from the inscribed angle, is going to be twice the measure of the angle. So 2 times 39 degrees gives you the measure of the arc, which is 78 degrees. So that means that the measure of HJ is 78 degrees, 78 degrees. And we can also state a conclusion about the measure of angle HGJ, which is the same as the measure of angle HFJ, which is 39 degrees. And we know this because they are congruent, because they share the same intercepted arc.
So for an intersection of a tangent and a chord, if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So here's our tangent line, and here's our chord. So if they intersect at that point of tangency, you have one angle formed, angle 1, the measurement of angle 1 is going to be half of the arc BA. So we should write that down. The measurement of angle 1 is 1/2 the measurement of arc BA. So same thing with the other side. You have an other angle formed, angle 2. That's measurement, or angle 2's measurement is going to be half the measurement of angle BCA. So these are two properties that are involving a chord and a tangent if they intersect on a circle. So then taking that property, example 1, we have to find the angle measurements and the arc measures. So line M is tangent to the circle. We have to find the indicated measure. So in example 1A, here's our tangent line, and we have chord BA that intersects with tangent line M at the point of tangency A, which forms angle 1. Angle 1, that measurement, is half the measurement of its intercepted arc. So to figure out what the measurement of angle 1 is, we take angle 1 and take 1/2 of 132. So angle 1 is the measurement of angle 1 is half of 132. So the measurement of angle 1 is going to be 66. Now if we look at B, we want to find the measurement of arc EFD. So they already give us the angle that the tangent line and the chord forms. So we know that this angle is always going to be half the measurement of its intercepted arc. So in this case it's DFE. So if we need to find the measurement of the intercepted arc, we can set up our equation where the measurement of angle EFD equals 2 times the measurement of 110. So we're actually working backwards here. We know that this arc is going to be double the size of the angle that's given, so if we just multiply this angle by 2, we can get our our arc measurement of EFD. So the measurement of arc EFD is 2 times 110, which ends up being 220.
Intersection of a tangent and radius. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its end point. So you can see that we have a tangent line on the outside and that intersects the radius OP on the inside of the circle, and where they intersect they form a right angle. So we can say that the line MP is tangent because it intersects the circle at a right angle. In example 3, we want to verify if ST is tangent to the circle. In this diagram, RS is the radius, is ST the tangent. So what we want to figure out is if where the radius intersects the supposed tangent, is that perpendicular? In order for that to be perpendicular, which means that if ST is tangent, then that means that triangle RST must be a right triangle, because right triangles, that would make angle S that right angle. So we need to verify if, using the Pythagorean converse, if c squared is actually equal to a squared plus b squared. So let's start with c squared. Well, across from our supposed right angle, angle S is 26, so that's my hypotenuse squared, and you can choose either of the other two sides for a squared and b squared. So we want to see if that is equal to 10 squared plus 24 squared. So let's do some computing. 26 squared is 676. Let's see if that is equal to 100 plus 576. Well, 676 is equal to 676. Since those are equal, then we can say that angle S is a right angle, which makes ST tangent to circle R. In example 4, in the diagram, B is a point of tangency. Find the radius R of circle C. So in this problem, we already know that triangle ABC is a right triangle because point B is a point of tangency. So that must mean that c squared is equal to a squared plus b squared, because the radius R intersects B at a right angle, which then makes triangle ABC a right triangle. So if we want to solve for the radius, we can use the Pythagorean theorem in order to solve for that radius r. So let's start with finding c, because we should always identify our hypotenuse first. Well, if point B is a tangent, is the point of tangent C, then that means that angle B is the right angle, which across from the right angle is my hypotenuse AC. Now my hypotenuse is the whole entire side AC, which means I have to add both parts of it, 49 plus r. So in for C, I'm going to write 49 plus r and then square that entire quantity. Now for A and B, I can choose either of my two remaining legs. I'm going to choose r for A squared and 77 for B squared. Now let's do some multiplying. So 49 plus r is actually two binomials being multiplied together. We're not just squaring each term, we're actually taking the whole entire term and multiplying it twice. So that's rewritten as the quantity of 49 plus r times the quantity of 49 plus r, which is equal to r squared plus 5,929. So how do we multiply those two binomials? Well, I'm going to show you how to multiply them using the box method. So each parts of the binomial go on the top. Up here, 49 and r, both are positive, and the second on the side, 49 and r, again, both positive. Then you multiply the top of the box and the side of the box for each of the four boxes in this entire big square. So 49 times 49 is 2,401. 49 times r is 49r. 49 times r is 49r. And r times r is r squared. So let's rewrite that as an expression. 2,401 plus 49r plus 49r plus r squared is equal to r squared plus 5,929. So let's combine some like terms. 49r and 49r can combine to form 98r. Add in our r squared, which is equal to our right-hand side. And now we need to solve for r. Well, I noticed that we have an r squared on the right-hand side, so I'm going to bring that over to the left-hand side. And actually, what happens, we have a positive r squared minus r squared. Those end up canceling out. So I'm going to go ahead and jump to the next step since I'm running out of room also. I need to isolate r by itself. So I need to keep this r, the only r that's left over at this point, on this side of the equation. So I'm going to subtract 2,401, bring it to the right-hand side. So now I'm left with 98r is equal to 3,528. When I divide by 98, I have my solution for r, which is 36. So we have now solved for the radius, which is 36.
Alright, for the angles inside the circles theorem, if two chords intersect inside of a circle, so we have one chord here and one chord here intersecting inside the circle, then the measurement of each angle is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So if I focus on angle 1, we have the measurement of angle 1, which is right here. So we're going to highlight that to show where it's at. Now that measurement is equal to 1/2 of its intercepted arc DC and its vertical angle's intercepted arc as well. So its vertical angle is right here, so then its intercepted arc is AB. So if you take 1/2 and add arc DC as well as its vertical angle AB, its vertical angle's intercepted arc AB, that should give you the measurement of this specific angle 1. And if you keep observing the picture, we have an angle 1 and angle 2 right next to each other on a straight line. Well, just a little side note here, these two angles, if they're right next to each other, they are going to be supplementary. You guys remember that? Okay. Alright, so for example 2, we have to find the angle measurement inside the circle. So we have to find the value of x. The chord FH and GH are intersecting inside the circle. So we have an angle right here. So we know by the property that this angle is equal to half the measurement of its intercepted arc as well as its vertical angles intercept the arc. So let's set up our relationship. So there's our angle x. That's equal to 1/2 the arc AGH. I should put down measurement, but we're talking about the measurement of GH, plus the measurement of its vertical angles intercepted arc FJ. So substitute what we know. We know the measurement of the arc of GH is equal to 140. And then the measurement of its vertical angles intercepted arc is equal to 112. So then I simplify further. X equals 1/2 252. Divide that by 2. So the angle measurement for x is equal to 126 degrees.